Welcome to Learning Math with Mr. Tan. Today I'll be talking about solving quadratic inequalities, but first I'll talk a little bit about solving quadratic equations. In the example on the left, we have solve x squared minus 2x equals to 15. And we all know that the right hand side of the equation has to be 0, so subtracting 15 on both sides of the equation, I'll get x squared minus 2x minus 15 equals to 0. And then factorizing the left hand side of the equation, I'll get x plus 3 multiplied with x minus 5 equals to 0. And then next we will apply the zero product rule, and I will get x plus 3 equals to 0 or x minus 5 equals to 0. And then our solutions would be x equals to negative 3 or x equals to 5. If I were to represent these two solutions graphically, that's like sketching the graph of y equals to x plus 3 multiplied with x minus 5. So this curve over here, right? This is the curve of y equals to x plus 3 multiplied with x minus 5. And then the solutions would actually be the points of intersection between the curve and the x-axis. Right? So these two solutions are represented by these 2 points that are marked in with a solid circle. Right, next, so we try to solve the example in the middle where we have x squared minus 2x greater than 15. So following the same step, I will subtract 15 on both sides of that inequality. Right, so we have x squared minus 2x minus 15 greater than 0. And then we will also factorize the left hand side. So I get x plus 3 multiplied with x minus 5 greater than 0. So far so good. But this is the point where it will start to diverge away from the way we solve quadratic equations. Alright, so here, let me use a different color ink to do a bit of elaborating here. So if I were to solve this x plus 3 multiplied with x minus 5 greater than 0, it's equivalent to saying, for example, if I were to sketch the graph of y equals to x plus 3 multiplied with x minus 5, and at the same time x plus 3 multiplied with x minus 5, we know that it's supposed to be greater than 0. That is equivalent to saying that we're looking for the values of x that will give us all the y coordinates positive. Alright, so say again, we're actually looking for the values of x whereby all the y coordinates on that part of the graph are positive. So if you were to think about it from the graphical point of view, when we say that y coordinates are positive, it is actually the parts of the graph whereby it is above the x-axis. So what this means for us is actually essentially we're looking for the parts of the graph where it's above x-axis. Alright? So consequently, because the coefficient of x squared is positive, this is like a smiling kind of graph, and then so the parts of the graph where it will be above the x-axis would actually be these 2 parts. So let me try to highlight these 2 parts. Alright, these are the 2 parts of the graph where it's above the x-axis. And we know that the intersection with the x-axis is negative 3 and 5. Alright, and the inequality involved here, just a very small point, is that it's small but important, is that it is a greater than relationship. So therefore there is no equality. So therefore we shall just use an empty circle for each of the x equals to negative 3 and x equals to 5, just to indicate that we don't want the exact value of 5 and negative 3. But we also want to show the kind of intersection with the x-axis. So far so good. We've now identified the parts of the graph that we are looking for. So contrast this with the quadratic equation situation. That's where we're just looking for the two, right? The two points of intersection with the x-axis, because we want to set the y equals to 0, right? So let me elaborate a little bit here, and let's just bring in the equations part again. So it's like saying I'm sketching y equals to x plus 3 multiplied with x minus 5, and then x plus 3 multiplied with x minus 5 is also equals to 0. So we're looking for the values of x. We were looking for the values of x where it will give us y equals to 0. And we know that y equals to 0 is essentially actually the x-axis. So conceptually, this means that we're looking for the values of x whereby the part of the graph is actually at the x-axis itself, which in other words, you know that it's the x-intercept. So that's how we relate why we need a different approach to solving quadratic inequality. So now at this point we have identified the parts of the graph, right? So come back to the middle example. We have identified the parts of the graph where it is above x-axis, but we're not done yet, because when we are solving an equation, or when we are solving an inequality, we are looking actually for the values of x, or the range of values of x. So therefore we're not done. We only identified parts of the graph where the y values are all positive. Next is, then what are the values of x that will give us these positive values of y? So I'm going to have to erase some of the annotations here, right? And just give me a while. Right, so correspondingly, let me try to zoom in here. Correspondingly, these values of y actually corresponds this way to this part of the x-axis. So essentially, I'm trying to say that the parts of the x-axis that we want are those on the right of 5 and on the left of -3. So if I were to remove the arrows, alright, I forgot the x over here, and the parts of the x-axis that we want and we have identified is actually this part, alright, like I said, to the right of 5 and to the left of -3. So in solving for the original inequality, we would say that the final answer would be x is greater than 5, right? Or x is less than -3, and we're done. So in solving quadratic inequalities, we definitely would need to sketch the graph to help us identify the parts of the answer that we want. So we actually want these two parts, all right? So next, I will talk a little bit about what's the difference then if it's a lesser than sign. So I have kept everything the same, so we can see the differences between the three ways of solving, right? And for the third example on the right hand side, again, I'm going to repeat all the same steps. So now I shall not elaborate so much. Right, again, same thing, x plus 3 multiplied with x minus 5 less than 0. So again, applying the same trail of thoughts, I'll say that we're looking for the values of y if we were to sketch the graph such that y is the values of y are all less than 0. So that means these are negative y values. So these these values will come from the part of the graph where it's below x-axis. Okay, so that's the understanding. So we are actually looking for, if I were to zoom in to the sketch here, okay, again, let me put in the x first. So we're actually looking for this part of the graph. So I'll have to be very careful not to touch the x-axis. All right, and again, same thing, there's no equality, so I'm just going to put two empty circles, -3 and 5. So the pink color highlighted part is the one that we're looking for, and this is the part where it is this is the part where it's below x-axis. Alright, so this is what we want. Now, correspondingly, this part of the graph will correspond to this part of the x-axis. Alright, so that's what we want. So I'm going to erase all these arrows once this is clear. So actually, the part of the x-axis that we want is actually this in-between region. Alright, so that would translate to an answer of, let me erase the annotations here. Right, so that will translate to this answer of x is between 5 and -3. So what happens if we are asked to solve negative x squared plus 2x plus 15 greater than 0? Does that mean to say because the coefficient of x squared is negative, we need to sketch a set curve? Well, no need. Alright, we can also factorize out a -1. Alright, leaving the negative sign outside of the bracket, and we have x squared minus 2x minus 15 inside the bracket, and that's greater than 0, as we see here. And then what we can do next is to divide both sides by -1. But take note, for equations, when you divide both sides by a negative number, no issue. Alright, no matter you divide or multiply by a negative number on both sides, right, the same number on both sides, no issue. However, for inequalities, when you divide or multiply both sides with the same negative number, you will need to flip the inequality sign. So here, what happens is we have x squared minus 2x minus 15 less than 0. And then from here, this is essentially the same thing as we've seen in the examples before. Alright, we can sketch a happy curve and then find the region that we are looking for and conclude. Alright, so that concludes my short video about solving quadratic inequalities. I hope this video helps you in solving quadratic inequalities, and this is one of the first 1 or 2 topics in additional mathematics at upper secondary level, and I hope this helps you to solve quadratic inequalities. So until the next video, study hard, take care. Alright, goodbye.